Welcome everybody. In the previous video, we mentioned the meaning of rational number. A rational number is a number that can be expressed as a fraction. A is divided by B. And now in today's class, we try to look at the rational numbers in a different way. So let's look at the question here. Are all the decimals rational numbers? This question is the same as saying that, can all the decimal numbers be expressed as a fraction A is divided by B? And we did a couple of examples already previously, and let's check out a couple of them. For example, 0.7. 0.7 here can definitely be written as a rational number. 7 is divided by 10. And then some numbers like 7.5 can be written as 75 is divided by 10 as a rational number. So I think this question we can talk about it in a deeper way. Now my question is, can all the decimals be expressed as rational numbers? Please think about it yourself. Let us try to classify different kind of decimals first. I believe they are in your mind already. The first one, we call it terminating decimals. It basically means that the decimals themselves, they are finite, which means maybe 0.3, 0.4948. This kind of decimal numbers, they have finite ends, which means you're going to end the numbers after the dot somewhere anyway. The second type, we call it repeating decimals. It means that the decimal itself has an infinite end behind the dot, and the pattern keeps repeating itself. For example, maybe 0.3333 and so on, or maybe 0.4949 and so on, or 0.721, which is not a repeating pattern at the beginning, but ultimately you'll get a repeating pattern anyway. For example, 171717, and it keeps going. So the same pattern 17, it keeps going here without the first three numbers 7 to 1. So all of these are repeating decimals, so which means that there's a last type of decimal. We simply call it non-repeating. It basically means that the decimal numbers itself does not have a repeating pattern, and also it doesn't end definitely, so there's an infinite end. For example, I can randomly give you a number. So basically you randomly keep writing any numbers without any pattern infinitely, you'll get a non-repeating decimals. Now the curious fact is that all rational numbers that can be expressed as a fractions, they must be either repeating decimals or terminating decimals. It basically means that if I write down the irrational number here to be defined as the numbers that are not rational, which means irrational numbers are all the numbers that cannot be expressed as a fraction A is divided by B. Logically speaking, irrational numbers contains the class of non-terminating decimals. Just a simple example for you here. If you talk about the number square root of 2, and you can try to use calculator here, you'll get the number 1.4142, etc. And this pattern is not repeating itself, and furthermore it is infinite. And this number, as I said above here, it cannot be expressed as a rational number A over B, and square root of 2 is definitely one of the examples of irrational numbers. So lastly, we define real numbers to be the numbers either they are either rational or irrational numbers. It basically contains all the classes of numbers we have been talking about since the previous video: whole number, natural number, integers, rational numbers, and irrational numbers. They are all contained in the class of real numbers. Let's make a brief summary of today's class. And the first one, we talk about the rational numbers. To put it the other way, we can say rational numbers are the decimals that are either terminating or repeating. And then we talk about the irrational numbers. They're basically the decimals that are non-repeating. And real numbers, they basically just contain all the rational and irrational numbers we have been talking about. So it's basically the end of this class, and there's one interesting question for some of you who are more interested in the advanced level of understanding. Let me put the question here. The question is that As you know, expressing a rational fraction, rational number a is divided by b into a decimal is a very easy process. You can simply do the division yourself, or you can do it by calculator. But now my question is basically the inverse process. And as I said before, rational number include two classes of decimals. The first class is the terminating one. If you try to express the terminating decimals as rational numbers, it's actually not a difficult process because, for example, if you have 0.3, you can simply write it down as 3 over 10 here, or maybe 5.7, you can write it down as 57 over 10. So it's actually an easy process for the class of terminating decimals. But for the class of repeating decimals, how can you do it? Just as a simple example, for 0.1717171717 and so on, do you know how to write it down as a rational number, as a fraction? It's not an obvious process here. So in the next video, we'll dedicate this problem to the next video and talk about the constructive way to find a fraction that represent the repeating decimals. And just a brief preview for the next class is gonna be a little bit more advanced. If you're not interested in that, you can skip the next video. Anyway, I stopped the video today here. Thank you everybody.